To finish our last example from class on Wednesday, we started talking about how to use power series to solve differential equations, and then we did our first second degree differential equation, y double prime equals y. And the strategy here is you let y be a power series centered at x. Using what we know about power series, we can find y prime and then y double prime. And then letting y double prime be plugged into the left side and y plugged into the right, you get this series of equations which we went over in class. And this led to our recurrences, which we solved, and we eventually got to the point where we wrote our solution as y equals this sum. So we get a over 2n factorial x to the 2n plus b over 2n plus 1 factorial x to the 2n plus 1. And it turns out that these are power series that we've talked about before. So to recognize them, I'm going to bring the a out of the first sum. So this is going to be the sum of a. So a times the sum from 0 to infinity of 1 over 2n factorial x to the 2n plus b times this other sum. So the sum from 0 to infinity, 1 over 2n plus 1 factorial, x to the 2n plus 1. And these are both power series for known functions. So this first one is a power series for hyperbolic cosine. So this is a hyperbolic cosine of x plus b sinh of x, hyperbolic sine. And so that's our solution. That's going to be the values that solve this differential equation. Now, this is a differential equation that we could have solved a long time ago, so a few weeks ago. And so if you remember, we started with y double prime equals y. That's equivalent to saying y double prime minus y equals 0. This leads us to study the characteristic equation r squared minus 1 is 0, whose solutions are plus or minus 1. And so that means that based on our methods from before, you would get y as c1 e to the x plus c2 e to the negative x. And that is in fact what we get if you remember what hyperbolic cosine and hyperbolic sine really are. So just to verify that these are the same, let me siphon off our work there. We're going to get that a hyperbolic cosine and b hyperbolic sine, remember they can be written as, hyperbolic cosine can be written as e to the x plus e to the negative x over 2. And likewise, hyperbolic sine can be written as b times e to the x minus e to the negative x over 2. Okay, so the only difference there being the sign between the terms in the numerator. Okay, a plus versus a minus. And if you rearrange, this turns out to be, you can write this as a over 2 plus b over 2 e to the x plus a over 2, quantity a over 2 minus b over 2 e to the negative x. And we really do have c1 e to the x plus c2 e to the negative x.